Hello, nice to meet everyone digitally today. My name is Molly, and I'm head of content and community at Monte Carlo, a data reliability company. We build a data observability platform. So today we're going to talk about how this new layer of your data stack actually comes into play into practice to help you ensure data trust and actually address a lot of the big problems that Sean mentioned earlier today about data integrity and data reliability. And then Patrick is on Optoro, or leads Optoro's data engineering team. So he'll be talking a little bit about how Optoro uses data observability in their modern data stack. Yes, so so a little bit of background about us. So my name's Molly. Prior to joining Monte Carlo, I led Uber's engineering blog team and worked with the office of the CTO to help data teams and engineering teams communicate about the tools that they were using and building. And prior to that, I was a freelancer at USA Today. And before that, I received my BA from Stanford in American Studies. And I'll let Patrick introduce himself.
Yes, thanks, Molly. Also very happy to be here today. I'm Patrick Campbell. I lead data engineering at Optoro. After graduating computer science at the University of Maryland, I co-founded an ed tech company before starting at Catalyst. Catalyst was a voter information data company where I started my data engineering career in Washington, D.C. And for the last 5 years, I've been at Optoro building our data infrastructure and now manage the data engineering team. And quick plug that Optoro is hiring data engineers, and I'll have ways for you to connect with me or apply at the end of this.
Awesome. Thanks, Patrick. So I will spend the first portion of this presentation explaining what data observability is. So as you know, everyone at your company relies on data. You have the data end users, so Reliant Rebeccas, who are sales agents, marketing managers, account managers, so on and so forth, leveraging data that your team is producing. Analyst Anna, so you have the analysts who are advanced in SQL and spreadsheet wranglers, and they are using the data that engineer Emerson actually kind of makes operational and usable. And then at the other side of that, you have the manager of the data team who, relies on those reports and insights to power her stakeholders' decision makings. So at the end of the day, the data needs to be compliant, accessible, and accurate. Next slide. But when downstream consumers like managers or Reliant Rebecca tell you that the data is wrong, next slide, you've got a serious problem on your hands. So as you know, data can break for a million different reasons. Data can break as a result of, during transformation, integration, as a result of manual data entry errors, migrations to different technologies, broken APIs, so on and so forth. And often for data engineers, schema changes are a #1 cause of data issues and data breakages. And this can cause a lot of problems. So not only are you wasting time and resources handling these issues, you're at risk of compliance infringements and even erosion of data trust. So if your consumers and stakeholders can't trust your data, that's bad. Next slide, please. And as I mentioned, everyone relies on this data, and if you can't trust it, then you have a problem on your hands. So we actually call this problem the cone of bad data anxiety. So that refers to, everyone kind of on the receiving end of the data and how big of an issue it is if the data is wrong when it gets to them. So we have, the data engineer at one end, so Patrick, the data analyst in the middle, who's kind of using the tooling and creating reports, and then the data consumers. So as it moves down this cone of anxiety, the problems can get more serious and it can get more difficult to resolve. So if you've been at the receiving end of this problem, you're probably no stranger to what we call data downtime. Next slide, please. So data downtime refers to, periods of time where you can't trust your data, essentially. And it kind of harkens back to the early days of the internet. So back then, online applications were a nice to have. And if they were down for a while, it was not a big deal. This was like 20, 25 years ago. You could afford downtime since businesses were not overly reliant on them. But we're now 2 decades in, and online applications are mission critical to any business. As a result, companies measure downtime meticulously and do everything that they can to prevent service interruptions from happening. And so similarly, in 2021, during the decade of data, companies are increasingly reliant on data to run their daily operations and power their digital tools and products. So what we believe is that teams are not really treating downtime with a holistic end-to-end approach, the approach that they deserve. So next slide, please. So, application engineers have this approach called observability. So monitoring and observability is used to identify when data issues happen, so that application issues happen, so that site reliability engineers and DevOps team can address them appropriately. So much in the same way that engineering teams rely on observability solutions like New Relic and Datadog to monitor for application downtime, measuring traces, logs, and metrics as signals of application health, there's a new way forward for data engineers. Next slide, please. So we like to refer to this solution as data observability. And data observability can be used to monitor and alert for data issues in your pipeline, kind of in a proactive way. So by leveraging machine learning and automation, data observability can actually learn your data patterns so that when data anomalies or other issues occur, your data engineering team will be the first to know so that they can address it. And it goes beyond what standard testing and automated checks can account for, because it gives you a holistic look at your entire data ecosystem. So we have, next slide, please. 5 key things that we look for when it comes to measuring the data health through observability. So freshness, distribution, volume, schema, and lineage. And that I'm sure you are familiar with those terms, and you use those to measure the health of your data every day. So the first pillar is freshness. So as I mentioned, next slide, please. So as I mentioned, data pipelines can break for a million different reasons, but one of the primary culprits is actually freshness. So freshness is the notion of, is my data up to date? What is its recency? Are there gaps in time when the data hasn't been updated? And how do I know about that? Next slide, please. The second pillar is distribution, which relates to your data assets' field level health. So null values are one metric that helps us understand the distribution of a given field. And so data observability actually lets you know whether or not that field, that field exists and if there are issues. So for example, if you have a particular field and you typically expect a significant or specific % of null rate, then suddenly that spikes up in a really big way, you probably have a problem on your hands and you should know about it. Next slide, please. The third pillar is volume, kind of self-explanatory. So it refers to how much data is in a field or a database, and it kind of tells you whether or not your data intake is meeting thresholds. So it also refers to the completeness of your data. So if you have 200 million rows, as an example, which is a lot, and it suddenly drops to 5 million, you should know. Next slide, please. The fourth pillar is schema. And so I know this is a really, really big sticking point for a lot of data engineers when schema breaks. And as Scott explained, it's actually the #1 reason for that data engineer site for pipelines breaking. So oftentimes we find that schema changes are the culprits of data downtime incidents and can cause a lot of problems downstream. So this happens when fields are added or removed, changed, tables are removed or not loaded properly, etc. And we're often finding out about it too late. So auditing or having a strong audit of your schema is a good way to think about the health of your data as part of this observability framework. And then finally, the final pillar is Lineage. So perhaps this is the most holistic one. So Lineage actually helps you put all of the 4 preceding pillars together to understand the map of your data health and see, what data, when data downtime happens, who is affected, what tables were affected, who needs to be reported, what reports need to be updated. And it really, in Lineage, gives you kind of an answer to these questions by telling you which upstream and downstream sources were impacted and what teams are generating the data and who is accessing it. So before I hand it off to Patrick, next slide, please. Just kind of the overall high-level value that we've seen teams have by using data observability is obviously cost savings. We had one fintech company estimate that it would take them about $500,000 to actually build their own data observability platform. Time savings, another company says that data observability saves them about 120 hours per week in time that would be spent, resolving these or trying to figure out the root cause of these issues. And then finally, it drives greater efficiency and collaboration between analysts and data engineers, which Patrick will talk about, which I know is a huge sticking point as data engineering really comes into its own as a critical component of the data organization. So with that, I will hand it off to Patrick to talk about how his team leverages data observability in practice.
All right, thanks, Molly. Now that we're familiar with the data observability pillars, I'd like to share a bit about Optoro's story. So the key pain points in our data infrastructure have to do with data integrity and building trust with our data consumers. You can go to next slide, please. So quick overview on Optoro. Optoro's mission is to eliminate all waste from returns. Our technology platform connects every returned item to its next best home, thereby increasing profitability for retailers, giving consumers great deals, and reducing environmental waste. As you can imagine, the system creates many mission-critical data points as we route returned inventory through our system. So here's a high-level overview of our stack. The arrow in the picture here is our event messaging system. The operational databases towards the bottom here, that's one of the many connectors that we use in Fivetran, and our Snowflake single source of truth for data is on the right-hand side here. Monte Carlo is connected directly to Snowflake, as is Airflow, where we run transformation jobs and our DBT models from. And then furthest to our right, we have the larger internal end users, the analytics teams, the data quality teams, data science teams, also our clients using our Looker dashboards. So next slide. So here, the lack of data integrity. So we need insight into the quality of our data, plain and simple. We didn't have a good method for understanding when data might be missing, when it might go stale, or if the data isn't what we expected. These problems, when not observed, feed data directly to clients, who are then the first to let us know. This is obviously a problem. This causes mistrust in our data and produces mistrust in our ability to deliver reliable information about the inventory our software manages. Our options here really boil down to build or buy. So build a custom SQL integrity checker that's brittle and expensive to maintain. Data engineering would end up owning this long term, which is likely not a great solution for us. Our second option, build source and destination checks into our data models with DBT, but only for a limited number of data models we've refactored from some of our plain SQL transformations. So the footprint of DBT is not too large at Optoro quite yet. Or we can create a POC, proof of concept, with the Monte Carlo team and see how far we can get into solving these issues. Next slide. So the POC here. So our mission statement, we'd like to test the data observability platform for some specific monitoring and alerting that may sound familiar to you all. So first, alerting on stale data products, like Molly mentioned. Being able to notify the team on large data pipeline changes, like a bootstrap or a larger load. Monitor when our operational databases safely fail over. Automatically generate rules based on expected data behavior. This was certainly a bonus that we've leaned into more kind of throughout the whole process with Monte Carlo. And lastly, the ability to write custom alerts to monitor specific use cases. So long story short here, we were able to provide enough value to prove the POC and build Monte Carlo alerting into our data engineering SDLC in about 3 months. So for this particular example below, we're using a custom rule breach alert on a data set that we ETL in Snowflake using a combination of DBT models and some of our 5-trend data sources. So it kind of gives you a picture of the whole stack kind of coming together with Monte Carlo keeping an eye on things. We can go to the next slide, please. So Lineage here. Once receiving an anomaly alert from Monte Carlo, let's say we have an alert on our operational database, 5-trend pipelines for failover in Kubernetes, we can get a visual on the affected data sources from internal data marts on the left all the way downstream to our looker reports that could be client-facing. Being able to quickly identify client-facing issues to be proactive is really the key to build trust in our data. This feature makes the data engineer's job much, much easier, I can tell you, definitely from experience here. And the potential impact to our clients means time and efficiency wasted in the warehouse directly in terms of like the logistics, like moving units around the warehouse. If we have downtime, it's a pretty major cost to our clients, which just isn't sustainable. Next slide, please. So if we're talking about how we scaled up this process, where we started, here's how we quickly moved from a POC to a full implementation. So by the time we'd finished the POC, we were already getting actionable data alerts on a subset of our data platform. So we just carved out a subset of our products and started monitoring there, and we were able to solve issues proactively, which is really what I wanted to see out of this. Data engineering created the framework to use Monte Carlo tools and was able to scale to our data quality teams, analytics, and data science teams rapidly. And Monte Carlo's team, just as a side note, has been super receptive to our feedback and have continued to add new features that we've already made use of. So after talking with our users recently, so users in the platform and further downstream in reporting or in BI, we've estimated we save about 4 hours of time per engineer every week. Not only is this a huge win for data engineering in terms of trying to track down the needle in the haystack issues, but being able to enable other data teams to help us keep trust in our data. So it's kind of that like data ownership, a little more data responsibility in the products that they're shipping. Data integrity really should be self-service, and your data engineers will thank you.
Awesome, thanks, Patrick. Yeah, so as Patrick mentioned, really excited. We were really happy to be here today to talk to you about data observability. If you're interested in learning more, we have a ton of awesome resources on montecarlo.com. We write blog articles at least a couple times a week about this topic and how data engineers are achieving data trust through observability. And as Patrick mentioned, Optoro is hiring, so reach out to him if you want to learn more about working on an awesome data engineering team solving really interesting problems at scale. So thank you for that. And then we have a couple resources in the slide deck. So next slide. If folks are interested in learning more just broadly about data observability and managing broken data pipelines, just reach out to us and we can share those with you.
Perfect. We do have some questions that have come in. I do want to remind everyone, if you do have a question, please ask the chat. We're actively monitoring it. We have one that came in, so I wanted to ping it over to you, team. What is your method for monitoring non-Snowflake table, view, query, and BI tools? You mentioned being able to monitor 5-trend and Operation DB failover.
Do you want to tackle that, Patrick?
Yeah, sure. So if we're talking about database failover specifically, we have alerts hooked into 5-trend, but also we're able to just notice that within the database. Let's say we have a bootstrap action happen. So we wipe and reload a bunch of tables. We get a freshness alert from Monte Carlo that we can either have the machine learning side of Monte Carlo take care of, or we can write some more explicit, like what is the max date of this range, and then alert on that. So outside of Snowflake in particular, we also have some like Python-based alerting systems that we run in Airflow, just to poll our different systems and make sure, like, if it has a webhook, we'll try to get some messages back to make sure that we're monitoring and staying vigilant, essentially, on actions that happen within our system. I mean, we ideally want all of these systems to fail over quietly. We still have some that do not, obviously. I think every organization has a few, but yeah, things that we want to kind of pull over into this new era of data observability.
Nice. Patrick, can you tell us how your data team is structured at Optoro? And then is anyone besides data engineers able to create alerts using Monte Carlo?
Yes, absolutely. So high-level overview of data at Optoro. We're actually recently part of our engineering organization. So we're collaborating more effectively with our tech and product teams about data and how to use it effectively. So data engineering is its own team, its own vertical in the engineering department, and we just collaborate a lot of times with the data quality teams, data scientists, and analytics. And I mention those specifically because they all have access to self-service with monitoring and alerting in Monte Carlo. I think that with those teams, a lot of the efficiency gains that I've seen have come from the catalog view, or like the data lineage. So it's one thing to say, okay, data engineering, you just go take care of these data pipelines, but another for other folks to say, how exactly did this data get here? What is the source of this data? Which team can I go back to, or tech and product team can I go back to that is the producer of this data to ask more questions? So I think putting these frameworks in place kind of takes data engineering out of being the I guess middleman or woman in these situations. So I think that it really is about like data empowerment here, and being able to self-service, I think was really key with the platform.
Nice. Speaking of tools, how can you describe how dbt is used internally, and then also who is able to create data models?
Yes. So use of dbt internally, we have like a data engineering set of models that does some light transformation on the event-based systems that we're ingesting into Snowflake. So let's say it's dropped in as a JSON blob, and we need to either flatten this data out or roll it up to aggregate into a different table. Data engineering does own those models, but still accepts contributions from other teams. More recently, our analytics teams have been increasingly developing in dbt. So they have a way that they can contribute to a separate Kubernetes image that is then run by our Airflow instance. So data engineering is not stuck being the bottleneck between the analytics department and getting them to the point where they have functional data products. So they can contribute this code, build it. Our Airflow systems will pull those images and then run the dbt models as needed. Obviously, there's oversight there because we don't want costs to get too crazy. But yeah, just keeping a monitor on that. But again, just really trying to empower the rest of the data org rather than build all the data marts or data products ourselves.
Yeah, you had mentioned that the data team is hiring at Optoro. Can you tell us how you plan to grow the team in the future?
Yes, how we plan to grow the team. So we recently, I guess, tripled the size of the team. I guess we will towards the end of the month, and we'll be hiring, I think, 1 to 2 more data engineers to join. So I think at this point, because we've moved into the separate vertical and we want to kind of land and expand our data engineering territory within our engineering org, I think to that point, we want to make our presence known, kind of open up any black boxes that the organization perceives as like data engineering products specifically, and start to collaborate more effectively on our event-based transport systems. So really getting our separate product teams and services spun up on emitting their own messages so that we can get like better point in time information and be a little more agile with how we pull data into our single source of truth.
Absolutely. We have one other question that came in from the viewers. Do you feel like, do you feel like you are solving the discovery use cases with catalog? There are many options out there, Admusen, Databook for OSS, and there are other vendors. Do you find that Monte Carlo can meet those use cases?
We use it mostly as like a supplementary data catalog. I think that the fact that the Monte Carlo system is able to build this lineage itself is pretty remarkable. I think that like this required little to no input from our data teams in terms of like structuring upstream and downstream dependencies. Unlike DBT, we also use as a data lineage product, but it is a little more baked into how the models relate to each other rather than just like reading in metadata from Snowflake and being able to produce it itself. So I would say you likely get more data cataloging features out of the products you just mentioned specifically. But since most of our data catalog or our data products are described within like our Confluence interface kind of in-house, we haven't kind of expanded into that second layer of data cataloging. So it's been great for our use case so far.
That's great. That's great. Well, really want to thank both of you for your time. It's been super informative.